Welcome to Creative World. In this video, we will learn how to find peak inverse voltage across reverse biased diodes in full wave rectifier bridge configuration. We know that in case of bridge rectifier configuration, at a time two diodes are in forward biased while remaining two diodes are in reverse biased. We are interested to find the peak inverse voltage equation across reverse biased diodes. In order to derive this equation, we are assuming that the positive half cycle of the input AC waveform is being applied across this bridge configuration. In this case, this terminal will be positive and this terminal will be negative. And these two diodes D1 and D2 will be in conducting or forward biased mode, while remaining two diodes will be in reverse biased mode. So the flow of current through this load resistor will be using this path. Now we will write Kirchhoff's voltage law equation for this closed loop in order to find peak inverse voltage across this diode D3. We will start from here. Current entering terminal is positive, so voltage across this diode D1 will be taken with positive sign. This voltage will be actually potential barrier voltage which will be appearing across this diode. Sometimes these voltage are known as forward voltage. Next, voltage across this load resistor will be taken with positive sign because current is entering from positive terminal, plus V peak out voltage. Next, current entering terminal is negative, so voltage across this diode D3 will be taken with negative sign VD3. And all of these will be equal to 0. Now we are interested to calculate voltage across this D3, so we have to place this voltage on the other hand side of equal and replace VD1 with its value, which is taken as 0.7 volt in case of silicon diode. We can rearrange this equation. So the equation of voltage VD3 will be equal to V peak output voltage plus 0.7 volt. Here VD3 is indicating that these voltage are in reverse biased direction across this diode. So these voltage will be considered as peak inverse voltage across this diode, which is equal to V peak output voltage plus 0.7. So we can say that whatever the value of peak voltage on output will be, those voltage plus 0.7 volt will be equal to peak inverse voltage across this diode. Now, as we discussed earlier, these two diodes are in reverse biased mode. So same peak inverse voltage will be appearing across this diode D4 as well. In order to prove this statement, we will form an other closed loop using this path. And the direction of current will be in clockwise direction. Now write KVL equation for this closed loop. Start from here. Current entering terminal is positive, so voltage across this diode D2 will be taken with positive sign. Next, current entering terminal is negative, so voltage across this diode D4 will be taken with negative sign. Next, current entering terminal is positive, so voltage across this load resistor will be taken with positive sign plus Vp out. Here Vp is peak voltage and out is representing output peak voltage, and all of these are equal to 0. Now we are interested to find voltage across this diode D4 because these voltage are appearing across this diode in reverse biased direction, and these will be considered as peak inverse voltage across this diode D4. So we have to place this VD4 on the other hand side of equal. It will become plus VD4 and replace VD2 with its value. Diode D2 is in conducting mode and we are assuming it is a silicon diode. So potential barrier or forward voltage across this diode D2 will be equal to 0.7 volt. Rearrange this equation. Voltage across D4 that are in reverse bias direction, and actually these voltage are considered as peak inverse voltage, will be equal to V peak output voltage plus 0.7. You may see that in both cases, both diodes will be having same peak inverse voltage across them. Here I have discussed only positive half cycle of the AC input waveform. You may take the negative half cycle across these two terminals as well. In this case, these two polarities will be reversed and the directions of currents will also be reversed along with these polarities across diodes. In that case, these two diodes will be having same maximum peak voltage across them in reverse bias direction. So from this discussion, we can generalize our equation for peak inverse voltage across reverse bias diode in full wave rectifiers bridge configuration. Peak inverse voltage across reverse bias diodes are equal to V peak output plus 0.7 volt. And in case of germanium based bridge rectifier, this 0.7 will be replaced with 0.3 volt. So this was all about peak inverse voltage across reverse biased diodes in full wave rectifier bridge configuration. Thank you. See you again in next video.